Hello everyone. Today I am going to solve the four interesting integral. In other words, this video is devoted to those students who are interested to find interesting integral and example of the integrals. So during the solving during the finding the answer of each integral, you will see I'm going to use the same strategy. Okay, the first one, e power x times sine x. So I'm gonna use the integration method by part. So part by part. E power x is the u, and sinus x sine x dx is dv. So in the left side I have to compute the derivatives. E power x, e power x, e power x. So never will stop. In the right side I have to find the integral. So sine x is minus cosine x, again one more time, minus sine x. So I will connect them. When I'm using this method, it means that I am doing 2 times part by part, so one and second time. And when I show the straight arrow, it means that I'm going to finish it by the one new integral. You will see what happens. So this integral equals e power x times minus cosine x. So minus then e power x sine x and minus plus. So e power x sine x. Then the last sentence is, the last part is the e power x sine x dx. So here we have e power x times sine x equals this one plus this one minus this one. So if I name it I, you will see in the right side I have another I, but with the negative sign. So I can bring it to the left side. So I will have 2i equals minus e x plus e power x sine x. So I'm looking for the answer of the I. So I equals minus e power x and also plus c. So I divide by 2. So then you will see, you saw in this integral again the first integral appeared in the right side, so I transfer it to the left side and then I calculate this. So it's the answer of the integral. For the next one also the same thing happen. You will see. Okay, integral power 3x dx. I can write secant power 3x as a secant times secant 2x. We know secant is 1 over cosine x. So now again I'm going to use the part by part method. So secant x here, secant power 2x dx in the right side. Left side, I have to find the derivative of the secant x is the secant x tangent x, and I'm not gonna continue. It's easy to find it because secant means that this. So minus now the derivative of the constant is 0, so this part is 0, another part is minus, so sine x over cosine power 2x. So I can write it as a sine x cosine over cosine. So it's a tangent. Another one is the secant. Okay, on the right side I have to find the integral. So we know secant power 2 is equal 1 plus tangent power 2x. So it's the tangent x plus minus. So the answer is secant x times tangent x minus integral of the secant x tangent power 2x dx. I know that 1 plus tangent power 2x equal to secant power 2x. So I can replace secant power 2x minus 1. So I will have secant x tangent x minus secant 3x dx. I'm going to extend the bracket, secant x dx. Okay, I know the answer of this because if you okay, I want to find the answer of this. It's a very famous integral. It's enough to multiply on the secant plus tangent x and divide. When you do it, you will see by variable change, if it's u, that one is the derivative of the u, is u prime. So the answer is ln secant x plus tangent x. So the answer is the ln of the u. So I have the answer of this. Now I'm going to, so we know the answer of this, but you see what happened here. If I name it I, then I equal secant x times tangent x minus again I plus something. So I can bring it to the left side. So 2i equal secant x times tangent x plus n secant x plus tangent x. Now it's enough to divide on 2. So I equals, copy and paste here, and plus c. So as you saw, again the same integral appears in the right side, and I had to bring it to the left side and do it. Of course, for cosecant power 3 we have to follow the same strategy. It's the same. Maybe some minus appears. Also, for the previous example, this method also is true for e power x or any power of e. For example, e power 2x or 3x or something, ax, or instead of sine x you may have cosine x or cosine ax, bx. You can have anything there. So for now is the turn of the third example. Okay. The first method that I can use is using this change variable sin x equal to tangent x. We can use this change variable, but we can use this variable change, but it's very costly. When we replace, then we will achieve to the one big fraction, and we have to separate it and solve one by one, and it's very time. We have to consume a lot of time to solve it. So it's better to find another solution. So it's the general solution. But I don't like this, so I prefer another one. And you will see how easy it can be solved. Okay. We can write it cosine of x sine p over 2 minus x. Now variable change, pi and 2x equal u. So minus x du, dx equal minus du. Now I replace. Let's see what happens. For the side or boundary, now I start, then I will find it. So sine x will be sine. From here we will have x equal p over 2 minus u. Here again sine plus minus d. Okay, if I put 0 here, then u will be pi over 2. Also, if I put here pi over 2 would be 0. See what happens. Okay, if I change the boundary, I mean the side, then I have to put one extra minus. This extra minus times this minus will be positive, so I will change it. Okay, sine, I know this one is equal to cosine u. Here also cosine u plus sine u du. Okay, now let's see what happened. This one is I. This one is the same. Also, this one is also I. So let's see, when I find I plus I. I can easily change the name of the variable. Okay, x. So plus cosine x plus x. So let's see what happens. Okay, this one is 1. So x equals p over 2. But 2I equal p over 2. So I is p over 4. So we are done. Okay. The next example is the extension of the previous example. Okay, it's a general form of this example. So let's solve it. 0a x a minus x plus x dx. Okay, variable change u d minus dx du dx equals minus du. Let's see what happened here. F from here I will have x equals a minus u a minus u, then here fu plus f a minus u minus du. But for here also, if I put 0, I will have a. If I put a, then I will have 0. Again, I will change the boundaries, so another minus appears, and then you will see the minus times minus will be plus. So 0 a f a minus u du f u f a minus u. Okay, again, I can easily change the name of the variable. Okay, a minus x, 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 because it's dependent from the name of the variable. So if it's I, this one, we found this, so this one is also I. So I, we have one I. Let's see I plus I. What's the I plus I? So you will see, okay, 0a fx f a minus x plus fx plus f a minus x dx. This one is 1. So the answer is x. Then when I replace substitute the value of the boundaries, I will have a. So 2i equals a. So I equals a over 2. Okay, I hope you enjoyed the video and the examples, but although my English is not good, but I try to explain it by the language of the mathematics. In my channel there are more videos about the main topics of mathematics, especially in series and limits. I have many examples, although they are in the Persian language, but maybe you can follow the solution and learn many things. I hope you enjoyed, and thank you so much.